Yeah, it has started. I'll go on mute. You guys, you can continue.
Yeah, sure. Yeah, good morning, everyone. So I think Divya didn't attend on Friday. Atulya, Ganesh, you didn't come on Friday, right?
I think so. No.
Okay, fine. Okay, I think last class we covered about Docker, how to build, how to run. And after that on Friday, we covered Kubernetes. I will just try to quickly cover basics of Kubernetes, the concepts behind, and then try to set up a Kubernetes cluster in AWS. Yeah.
So you'll be sharing screen, right? So,
Yes, I'll just share it to you. Hope you guys are able to see the screen.
Yeah.
Okay. So see, we have covered Docker, right? So Docker is actually part of Kubernetes. So Docker is a small component in Kubernetes. Of course, it is the most essential part, right? So Docker, we are able to containerize the application and then we are able to run in a single system. Now we want to be able to run multiple containers in multiple systems, and we want to actually see it in a cohesive manner. So that is where Kubernetes comes into picture. Kubernetes is a container orchestration tool developed by Google. With Kubernetes, we can automate the deployment, we can do scaling and managing the containerized application across a distributed cluster of nodes. So I think this part, right? So when you talk about Docker, we just have Docker installed on a single system, right? So we run the Docker daemon, and then we make use of the Docker client to create the container, right? So we first write the Docker file, and then we create an image out of it, and then we start running that Docker container image. Now, in case of Kubernetes, which is the Kubernetes is the orchestration platform. So we are going to run multiple containers. We should be able to run, for example, some 500 containers in a system. So for running 500 containers, we cannot actually, rely on a single system. We need multiple systems. We want multiple servers put together as a single cluster, right? So let's say there are some 10, 15 systems, 15 servers. We bring up all the servers and then we create a software where the nodes talk to each other. After that, the user will be able to see a single cluster. You should be able to run multiple containerized applications here. So what is the advantage? Because we are running multiple systems, even if one of the server goes down, we will be able to run the container in another server, right? So say for example, some 15 systems are there. If two systems are down, still we will be able to manage with 13 systems, right? So maybe there is a little bit load, but still we are able to manage it, right? So there are times at which you want to actually upgrade the system, or sometimes you want to upgrade the hardware. So during this time you want to bring down the system and then try to do the deployment. So that is where Kubernetes is very helpful. So the advantage of the Kubernetes is it provides highly resilient infrastructure with zero downtime deployment capabilities. So we can do automatic rollback, scaling, and self-healing of containers, and high scalability of containers based on the metrics. So there is zero downtime. This is very important. So because we have multiple systems put together, even if some systems are down, we are still able to run the system. So you don't want to bring down the entire website just because some two systems are down, right? So sometimes nowadays, even for example, some ICC bank or HDFC bank is there, right? So they say that today we are going with a downtime. Okay, so we are going with the downtime, so you won't be able to access your website from this time to this time, right? So such kind of noisy mails you will get from such websites, right? So what is the reason? Because they cannot actually run the infrastructure running 24/7. They want to bring down the system down, then they want to actually do the upgrades, do the fixes, and then they say that from this time the system will be available, right? So this is not at all necessary with Kubernetes. Kubernetes is highly resilient infrastructure. So we also sometimes we want to do we want to keep upgrade the systems, right? Say for example, sometimes you will see, right, this is an older version of the website. For a newer version of the website, you click here. Do you want to make it permanent? You click here, right? So you may be seeing such kind of things. Do you remember that?
Yes.
Yes. So now go back to the old system. Also, you actually tell, right? So what is happening is, right. So there are two different type of images available in the system in the backend. So now you are going to a newer version. Sometimes you want to go back to the older version. They provide an option, right? You go back to the older version because you don't want like the newer version, sort of thing, right? So this is possible with Kubernetes, right? So the automatic rollback. So sometimes what happens is there may be issues with the new software. So they immediately want to go back to the older version. Now they don't want to give an option. See, we have actually upgraded, but it is giving some problems. Let's go back to the older system. So that is also possible here. Also scaling. Scaling is very essential, very important. For example, in e-commerce websites, there are times at which they give a lot of offers. Now, lakhs of people will be logging in at the same time. They want to search, they want to do some, some sort of research, and then they try to buy the items. Now if the website is very slow, people will give up, right? So according to the number of users who are accessing the system, you want to increase the number of servers in the system, right? So and number of applications running in the system. So with a limited number of servers, obviously you will get a bottleneck, and it will be slow, correct? So have you observed it? Yeah, Divya, Atulya.
Yeah. Yes. Yes.
Yes. So
Yes.
yes. So that kind of time you want to actually increase the number of servers, increase the number of containers which serves. So I will actually show some examples to how this is done. So all this is done with the simple commands, and then you can actually do it automatically as well. Like you always have some buffer, and say that if the number of user is this much, you want to have at least this many servers up and running. If the number of servers are going down, if the number of users are going down, you bring down the number of servers also. That way we can actually cost save with the server access as well, right? So everything is cost, right? So the number of servers are down means you'll actually save the cost in the cloud. So also the self healing of containers, and high scalability of containers based on the metrics. The metrics is what I said about the user. That is one scale. There are other multiple usage scenarios as well. So what is the disadvantage of Kubernetes? Kubernetes is hard to learn and manage. It's a little bit complex, like unlike Docker, which is just a single Docker daemon, and then you start running the Docker. Kubernetes is little hard because there are multiple components. We'll go through them, in the next slides. Because of this, it brings in a lot of complexity. So, and it really needs a good amount of expertise, and it needs some time to set up with a number of servers. So also it is resource intensive. So you cannot actually run a Kubernetes cluster and then say that I want to run something else there as well, because this itself is going to take a lot of resources. The Kubernetes software as such is going to consume a good amount of computing resources. On top of it, you are going to run your own applications there. So it's a very resource intensive. It's both memory as well as CPU intensive. Yeah. So we have seen a overview of Kubernetes. Any questions here?
No questions.
Sure. So let's go back to the architecture. So as I said, Kubernetes has multiple nodes. So mostly it is divided in two parts. One is the master node and then the worker node. So what is a master node? Master node is the control plane. When someone says control plane, actually this term they use it in the networking as well. So control plane is something where you actually control the entire cluster. Okay. Worker node. So worker node is where the actual applications are running. Say for example, if you are accessing a e-commerce website, you want to have database, front end, back end, all the applications to be up and running, right? So all those applications will be running in the worker node. So the control node will be always lesser in size. I mean, the number of control nodes is always less when you compare with the actual worker node. This is quite understandable, right? So you want to run multiple instances of the front end, back end, whatever required for the website, whatever required for web. It cannot be a website alone. It can be something related to enterprise applications as well. I'm just giving a small example. Okay. So in case of control plane, it is actually going to ensure that the cluster is up and running. All the nodes are connected well. Is there any problem in a node? What we need to do? Are we going to stop, running any containers in that specific node? All the decisions will be made in the control plane. So control plane will be keep monitoring the worker node, and actual workload will be running in the worker node. So the worker node will be again, pulling all the container images. The other day we have built Docker container images, right? We pushed somewhere, right? So from the registry, the worker node is going to pull the images, and then it is going to run the application, right? So let's see the different component here. So master node is the control panel of the Kubernetes. It manages the overall state of the cluster. So what are the different components here? API server, etcd, controller manager, and then scheduler. So the API server is the main and major component of the Kubernetes. It is a most important component of the Kubernetes. And then we have etcd, controller manager, scheduler. We will see what and all these component does in the following slides. Worker nodes. So worker nodes, in case of worker nodes, there are three important components. One is kubelet, another one is kube proxy, and another one is container runtime. Container runtime is nothing but a Docker daemon, right? So we have seen how to run a Docker daemon, right? Systemctl status Docker. So it is going to run the container runtime. Container runtime is required to run the containers, right? So as I said, Docker is a simple component of the entire Kubernetes cluster. So this is where the container runtime fits. Let's go through the components of master node and worker node one by one. So API server is the main component. It allows the user to communicate with the cluster and manage its resources. So now, like in case of Docker, we make use of Docker client. We say Docker build, we say Docker run, right? So we make use of the Docker client. A client is something which communicates with the server, right? Something similar to this, we will be making use of a simple client called kubectl. Kubectl is nothing but Kubernetes client. So you need to download the kubectl client, and then user make use of the kubectl client to communicate with the API server. So the user will be actually asking, I want to run a specific container with a specific memory, or he will say that I want to increase the number of containers to 5 or 4, something like that. So all this kind of request will be coming from the user. It goes to the API server. So API server is the one which allows user to communicate with the cluster and manage the resources. Okay, so API server is the main component. All the requests go through the API server. So API server sits in the master node. Okay, so etcd is a distributed key value storage. So whenever the user says that I want to add a specific node, I want to run a pod with a specific name, I want to create a service with a specific name. So just wait for some time. I will actually explain about all these nodes, pods, services in future. So the user requests multiple things. So we want to have this stored somewhere, right? So we want to say that the user is requesting a specific service with this name. The user is actually asking to run a pod with a specific name, and then we are having this many nodes. So we have this much memory which is available in this specific IP address. All these kind of informational things are stored in the etcd. So the request goes to the API server. API server in turn access the etcd and it stores some values. Okay, so it is for storage. So it is it is in itself a separate software. Okay, you can actually run a simple etcd server on your system, and you can actually try out different things like how the data is stored, how to remove, add, delete, all those things you can do with the etcd server, something like a Docker daemon. So this is another important component in master node. Let's go through the another one, controller manager. The controller manager is used to monitor the state of the cluster. So how the cluster is behaving, is it fine, like all the components are up and running or not? All these kinds of informational things will be monitored by the controller manager. It is in turn again a daemon. So it is one of the main component of the Kubernetes. So when the problem arises, it takes action to ensure the desired state is maintained. Okay. So whenever it sees that, that there is a lot of memory pressure in a specific system, it will move the containers from that worker node to another worker node. So this kind of monitoring is done by the controller manager. So it has something called replication controller. I want to have this many number of pods. This pods is nothing but containers. Just remember that. So we want to have this many number of containers. This kind of things are present in controller manager. And then the node controller is nothing but how the nodes behave. Is there any CPU pressure or memory pressure in the node? That kind of things will be monitored by the controller manager. We'll go to the next one, scheduler. Scheduler is responsible for scheduling the pod to run on the nodes in the cluster based on the resource requirements, and the scheduler check the workload. So it is going to actually check, like say for example, the user is asking, I want to run Nginx server, right? So now the request go to the API server. The API server just save the state in etcd saying that the user wants to run Nginx server with this name in etcd server, and then it goes to the scheduler. The scheduler is going to look at the nodes, how many nodes are available, how many replicas or how many containers the user wants to run. It checks, and then depending upon that and depending upon the load at the nodes, it will schedule, let's run the pod in a specific node. So it will decide actually depending upon how much resource is available in every node. So that kind of scheduling is done by the scheduler. All these are like like daemons or containers which runs in the master node. So and then we go for the worker node. So as I said, the actual workload of the user is going to run in the worker node. Worker node is another system, another server where the actual application is going to run. So as I said, the master node, worker node, everything put together is a cluster, right? So the request goes to the master node. The master node is going to select a node to run the container. So to run the container, we need some components in the worker node. One is kubelet. Kubelet is the agent that runs on each node.
Raghav, sorry to interrupt in between. You're going a
Yeah.
bit fast. I'm not able to follow. Can you say slowly?
Yeah. Okay, fine. Thanks. Sure. I'll go a little slow. So worker node is nothing but the node where we are going to run the actual applications, right? So we want to run some servers, right? At the end of the day, we'll be running something which is serving the users, correct?
Yes.
Yes. So we want to run the actual workload in the worker nodes. So there are three main components in a worker node. One is kubelet, kubeproxy, container runtime. So what is a kubelet? A kubelet is an agent that runs on each node, and it communicates with the API server to receive instructions for running the pods. So this is like a agent. It is actually going to run on every worker node. It is going to wait for request from the master node what to do, like what to do, how to run the pods. Okay, so it ensures that the containers are running in a pod and reports the node status to the master. So see, you asked me to run a pod. Pod is nothing but a container. So you asked me to run a pod. I'm running it, and my pod is running, behaving well. It report backs to the master node. Okay, so this is the one of the major component of worker node. And then we have kube proxy. What is a kube proxy? Kube proxy is a network proxy. It maintains network rules on the nodes. So when I say network rules, it means see, the other day we have seen Docker, right? So in Docker, at the end of the day, after running a Docker, you see IP address in the Docker container, correct? Do you remember that? Anyone remember using curl command the other day?
Yeah. To connect it, to connect to the Docker from outside.
Correct. So what kind of IP address it is? So basically what's going on is Docker in itself is maintaining a network state. Okay. So at the end of the day, you want to communicate with the application. How do you communicate with the application? You know, people say like there is something called network endpoint. I'm not sure how many of you from software like computer science background. All of you?
No.
I am.
So Atulya, Divya.
Yeah,
I
I
am.
am from computer science background.
Okay, good. So see, I'll just tell you, like, see, when you actually go through the networking part, right? So you might have remember, uh, all the connection endpoints are identified by four, things put together, like source IP address, source port, destination IP address, destination port. Do you remember these terms?
Yeah, yeah.
Okay. So what's happening is like,
Saruna, just
just to
give
give,
me 1 second. Uh,
yeah,
the way you said about, accessing from the public IP address, right? The containers running in
Yeah,
the
yes,
virtual
yes.
machine. So what Saruna is talking about is the private IP address of the Docker container, which is running inside the VM. So
Okay.
there are some communication happens between the Docker containers running inside the VM. So for that, he is explaining. Is it correct, Saruna?
yes, yes,
Yeah, got it, got it.
yeah. So, so say for example, like if you have a FTP server set up in your system, right? So a client is accessing the FTP server to download a file. Simple, right? So what the client is going to do? It is actually going to initiate a communication connection request using its own IP address, its own port. Okay. Now the FTP is being served in a specific IP address, and it is listening in a specific port. Okay. So client IP address, client port, server IP address, server port. So these four things put together is a socket. Like this is very basic. I think you know if you guys are going for interviews and all, this is one of the most important question actually. So this connection endpoint mechanism is very important for a client to communicate with the server. Okay. So similarly, when we set up the Docker container, this Docker is giving a IP address. Why we need IP address? Because it is actually serving something and we want to access it, right? As I said, this is very, very essential for the client to communicate with the server. So we are actually making use of a IP address there, and internally a port as well, right? Something like that. So in Kubernetes as well, we want to have IP addresses where multiple services are getting served. For example, there is a HCD running, there is a API server running, there is a kubelet running. All these services will be running in specific IP address and then specific ports. Okay, so they all communicate with each other because it's all a single system, right? So I mean single software, right? They know which port the kubelet is listening, which port the API server is listening. So such kind of information, everything know each other. So now when you actually run a container in a worker node, IP address will be assigned to that container, and rules will be written in the worker node saying that this IP address is actually running a container. So any user wants to communicate, they have to actually go through this specific, and then they reach the specific container. So that kind of rules will be written using kubeproxy. Okay. So the kubeproxy is the major component for networking. It is going to maintain the network rules on the nodes. So so see, actually Kubernetes is nothing but a set of all components put together, right? At the end of the day, we want all of them to communicate with each other. We want to run a container, and the container should be able to communicate with the outside world. So all the network related part is taken care by the kubeproxy. So remember it that way. Okay, going for the next, the container runtime. The container runtime is nothing but the Docker daemon. So now, actually, the Kubernetes community as such is moving away from the Docker container. They are actually going for something called CRI-O. At the end of the day, it is just a, another software, but it is a container runtime only. So it is not something very fancy or something like this is more standardized. Many companies are adopting it because it is more standardized. Apart from that, there is not much difference between Docker daemon and the CRIO. Yeah. So the next part will go.
Actually, I have a couple of questions. Sorry to
Yeah.
disturb you.
Yeah, sure.
The first question is, why is that etcd called distributed storage?
Yeah, good question. So I said like the HCD is running in the master node, right? So see, for example, you have some 50 nodes in a cluster. Let's consider, okay? If you have 50 nodes, you want to have master node set up in at least 3 nodes. Okay, so this you need to remember. Actually, it's not like a master node is a single node and all the other 40 nodes become worker node. That's not the case. You need at least some 2-3 systems to set up the master node, and then you can have any number of actually the number of worker nodes can be really big. Like in case of companies like Amazon, Flipkart, or Google, they go thousands actually. You're getting the point, right? So they are actually installing a single software in 1000 servers. It's just a single software. Like at the end of the day, it is a one cluster. So why we need to set up in three nodes? Because we want to ensure high availability. So every time a request hit the API server, the API server is going to store the information in HCD. The data is actually present in 3 different nodes. So even if one of the master node goes down, no issues. The HCD is again running in another node, and this is actually distributed. So it is across systems. The storage is accessed across the systems. So that way it is actually called a distributed data store. It is
Sure.
not like, usually you have a database. It is just a single database, right? Single database instance. And then you go and take a backup of that, right? That's not the case here. When you store, you are actually storing in, from 3 different servers.
Got it.
Yeah.
Another question is, in the architecture, like if we have multiple master nodes, each of the master nodes will be taking care of or will be monitoring the entire set of worker nodes. Like if we have 1,000, will each of those master nodes taking monitoring the entire 1,000, or is it like it can be separated? Like one master node is taking care of a certain set. Like how is the
Yeah, so this is where the beauty comes. Like there are a lot of different protocols used here. So one is called raft, RAFT. So you will be having the components running in all the systems, okay, but some of them will be active, some of them will be inactive. If one of the node goes down, the inactive one becomes immediately active. Okay, say for example, the controller manager is running in 3 different nodes as well. One of them will be taking care of it. Sometimes if the load is too high, they will share the workload among the controller manager as well, because all of them are accessing the HCD, which is a distributed data store. The information which they read is always same, whether you read from the master node 1 or master node 3, the information is going to be always same. You're getting the point, right? It is not like it is a single data store instance, but it is highly available. So at the end of the day, out of the 3, any of them can actually play a role, and they all actually share the workload. If the workload is too much, if the controller manager's workload is too much, they will share the work as well. Sometimes one of them goes inactive, another goes active. Why all this is very important is, as I said, it is having 0 downtime, right? So suddenly someone pulled a cable, right? So you let's say there are 3 master nodes, right? You suddenly goes and pulls power out of 2 master nodes, the system will be keep up and running. You got the point, right? So the active inactive state will transition very quickly, that you won't even notice it actually. So
right,
they all share the workload. Yeah.
Sure.
So it's very complex, like the kind of exchanges which are keep going on, like they say heartbeat actually, right? So whether the service is running or not, it will be keep checking it, and immediately if there is any issue, if there is a delay, it will start on the another node. Because you see, we cannot actually get any sort of bottleneck saying that one server is down, so my system is down. That is not okay here. So yeah.
Like another question is like, will each worker node have the components, the three components of that you mentioned, like kubelet, kubeproxy, and
Absolutely. Each and every worker node must have all these components. In case if the kubelet is crashing in one of the worker node, immediately that worker node will be monitored by the controller manager, and it will cordon. It will cordon in the sense, let's not serve any, let's not run any containers on this worker node. This worker node has some problem. So these three components must run on every worker node. Yes.
sure, got it. Thank you.
Yeah. So any other questions? So let's set up the simple cluster, and then we'll go. Are you able to see my screen?
Yeah, yes.
One second. For some reason, my note seems to be down. 1 second. Give me a minute.
Any questions for me, Saruna? You waiting?
I'm just trying to connect to that server. 1 second.
Sure, sure.
Actually, the